Good morning, good afternoon, good evening, wherever you're joining from today. My name is Magnus Mengelbier and I'm an independent consultant from southern Sweden. So this presentation is a result of working with R across multiple organizations, and it turns out that containers is actually one of the preferred architectures. So to start, we'll have a look at R. So we're going to treat at R as a language rather than an application for statistical analysis. Right? So R runs within an operating system. We use capabilities from packages to actually help perform our analysis, and we interact with R using some form of interface. It could be the R console, could be an integrated development environment like Workbench, or it could be predefined application code, say in a Shiny app. The one thing to keep in mind from this slide is that R code is not executed by the interface itself. It's actually passed to the R application. So that is where it actually executes. And that is also going to be to our benefit later on. Now, containers the term containers is being used interchangeably to mean different things. But essentially, for R, we're going to treat containers as a cheap virtual machine. Right? It's based on a container image, and the best analogy to a container image is essentially a big zip file that contains all the operating system files, or the files for R, all the files that you need for your packages and any other utilities. Right? But it has one specific attribute. If you put that image into a host and you launch it or turn it on, you get a container instance that you can interact with. So whenever users are interacting with a container, they're actually interacting with a container instance running in one of these hosts. Now, we create container images using script files, and I'm going to be using Docker architecture as our example. So here's a Docker file. It actually contains 3 parts. You start with some form of base or base image. In this case, it's Ubuntu, our operating system. Then you execute a set of commands to actually build your image. And once the image has been built, you would add the command that you need to run or you want to run when the image is launched as a container instance in the host. And that's where you would enable Workbench, or you would launch your Shiny app. Now, we just don't create one container image in most cases. We create container images for different purposes. As you see on the left, there's one for an interactive analysis environment based on Posit Workbench. And on the right, there's one for a Shiny app. These are different container images. That means they're actually created by different script files, which would also mean that if you need to validate a package for both container images, you would probably, if you're really following the rules, you would probably have to validate them for both individually. Right? And that's how most organizations approach containers today. Now, we want to be able to use R for GxP work, right? And as we're expanding the use of R within the industry and also within our organizations, so come some of the expectations around compliance and regulatory. And by approaching R as a language and also ensuring that the interface does not execute the R code, it's actually the R application itself that does it, we can actually simplify the compliance documentation we need to create. Qualification is essentially a set of predefined steps that would create a qualified environment. We can install R and utilities using the installation qualification. We can verify that the installed R application or any package or any features are actually operationally available. Doesn't mean that they're actually correct. We're just making sure that they're accessible and they can be used. Right? We use performance qualification to make sure that we can scale the environment as well for our business needs. The actual verification that a package does what it's supposed to do, and given certain inputs, the outputs are correct, we validate packages, right? And we can use different approaches that we can unit testing to test each function as a separate entity in an isolated way. We use integration testing when a function uses a resource external to our RMM, say like a database, or if we need to actually test wider process flows or other types of business processes, we can actually use user acceptance testing. But the most important thing, given that R is a language and also that the interfaces actually do not execute the R code, is actually done by the R application, we can actually use a simplified approach to our compliance needs. So we can use IQ, OQ for our interface, R, and any other utilities that we need to install. So the only thing that we really have to validate are the packages. Now, we can also use this approach when we're looking at containers. So we can either just put everything in container and do this documentation every time we rebuild the container image, right? And that's something we may actually have to do, because when we execute the script file, it executes from end to end, right? We cannot just select, we cannot execute parts of it at the time, right? But if we say that we split the containers, the big container, into two smaller containers, we will actually first build a container just based on the IQ/OQ documentation that we need to do. And then we use that as the source of building a second container, and that's where we actually install and validate all the packages. We can actually simplify the documentation and the validation effort. But interesting as well, if you look at the first container, that is actually an empty R environment with whatever interface you select to use. Right? So you can actually then use different package validation approaches depending on your needs. And this is actually how some organizations approach the use of containers within their business. Right? Either allowing the users to install packages using RNV or any other package management utility, or they actually create smaller collection or smaller containers that just has a predefined set of packages. Now, if we have multiple interfaces and we actually need the same packages across those interfaces, that just still means that we have to validate everything multiple times. So it would be really nice if we could actually validate the packages once and use everywhere. Now, there is actually an approach that we can use, and that is simply based on there's nothing that dictates that we have to do all the IQ/OQ based processes at the same time. So we could actually first create the R application in its own container, perform an IQ/OQ on that to provide the compliance documentation. Then we use that as a source for the container where we validate all the packages. And then we use that validated or that container with the validated packages as the source to add whatever interface we need to actually use or interact with R. Using this approach, we can actually validate the packages once, but then use them with whatever interface that we need. The only real time we actually need to rebuild the first container is actually when we decide to release a new version of R. So we can actually use container provenance in this case to actually start with an operating system. We can actually then create a container that just contains the build of R. And then we can add the validated packages to a new container that's based on the R build container. Now I'm calling that R container R batch, and that's simply because it's essentially R with packages. There's no real interface, but it's really a container that can be used for batch processing. And then once that R batch container has been validated and qualified, we can actually then use that container as the source to create containers with whatever interface that we need. Now, this approach works really well, but it does have one drawback. And that is because when we build a container, we're still running a script file end to end. So that means that whenever we create the R batch container, we are actually installing all those packages again and again and again, right? But we can actually look at R and containers to actually simplify that even more. And I'm going to use a use case. This is as an example of why it's such an issue. So this is a life science organization. It's single therapeutic area, and it uses R for primary and secondary analysis of clinical trial data. They're not doing anything exceptional, they're not doing any advanced statistics, but they still have 348 packages to validate. And that is a bit of a challenge if you think that you have to rerun the validation of all those 348 packages every time you recreate R batch. But we can actually turn to R to actually simplify that. We're going to use site library, which is essentially the worst case, is when you actually put all the packages into the same directory, right? But technically, the site library is actually defined by an environmental variable called rlib_site. It is not a single directory. It's actually a sequence of paths, and it's an ordered sequence of paths as well. So if we need to add a new set of validated or packages and validate them, we don't overwrite any of the previous blocks of packages. We actually just create a new block, number 4. We install our new packages into that directory, and those are the packages that we validate. So essentially, the way that would work is we'll still have our R build, like we do, but our R batch container image is actually built from or uses the previous production release of our batch as the source or the base image. Right? So we're taking whatever's been previously validated and released for production use, and we're simply just adding the new packages onto that. And then we use the new release of our batch as the source or base image for our interface containers. Right? So essentially, our batch becomes our golden image. That is the image that is actually used as a reference across all of these. The interesting thing with this approach is you're validating the packages once, but regardless if you are using an interactive analysis environment like a Workbench or using a Shiny app, you're actually using the same validated packages. So in summary, it's same R. Nothing. We haven't had to change anything when it comes to R. Right? We can retain the current compliance standards and processes that we already have. It works both with automated pipelines and manual processes. And we can use container provenance to actually simplify and decrease the validation effort. And it's something that we cannot do with traditional server architectures, where it's actually very difficult to do. Right? And also, that golden image would actually provide validated packages to containers regardless of what interface they use. So with that, my name is Magnus Mengelbier, and I share here with you my contact details. Thank you.